Stop!
Since the beginning of the space program, the world has been captivated by big, powerful rockets that can do it all with the help of their incredible propulsion systems. But what if there was a more powerful propulsion system in NASA's toolbox that could produce less than a pound of thrust while reaching great speeds? One such radical system that NASA is exploring is in space electric propulsion. It reduces the amount of propellant or fuel that's needed by up to 90% when compared to chemical propulsion systems. It hence saves millions in launch costs while making room for greater mission flexibility. An electric propulsion system uses energy collected by solar arrays or solar electric propulsion, or a nuclear reactor or nuclear electric propulsion to generate thrust. This eliminates the needs and limitations of storing propellants on board. The power is then converted and used to ionize, that is, positively charged inert propellants like krypton and xenon. A combination of electric and magnetic fields called the Hall effect thruster, or an electrostatic field called the graded ion, then accelerates the ions and pushes them out of the thruster. The spacecraft, therefore, reaches tremendous speeds over time. Once in space, the electric propulsion spacecraft is only limited by the gas in its tank. While the initial thrust is low, it can continue accelerating for months or even years. It can even slow down and go in directions. NASA's Dawn mission is a great example of this propulsion system. After launch, it's accelerated towards Vesta, one of the largest objects in the asteroid belt. The spacecraft's small solar arrays meant that it took 5 years to get there, but once it approached, it underwent a 180-degree flip, slowed down, and orbited Vesta for a year. Once down, it fired back and traveled to Ceres, a dwarf planet in Mars and Jupiter's asteroid belt. While these systems are widely used in the commercial sector, using electric propulsion for more complex missions, especially manned missions, will require more power and development. While NASA is looking into nuclear electric and nuclear thermal propulsions for its Artemis mission to the moon, Elon Musk's SpaceX is exploring yet another avenue in propulsion technology. For Artemis's human landing system, the Starship, SpaceX is designing the Raptor engine. One unique aspect of the Raptor engine is the use of subcooled liquid methane as a propellant. Methane prevents the buildup of deposits in the engine compared to fuels like kerosene, while its higher performance allows for lower costs. The Raptor's full-flow staged combustion engine will also use every drop of propellant available, making it one of the most efficient rocket engines ever built, while also giving it a much higher pressure. It's also believed that methane could be available on the Martian surface or elsewhere in space. So by mining water and carbon dioxide through in situ resource utilization or ISRU, the Starship will be able to take regular trips to and from Mars while remaining self-sufficient in terms of fuel. So it looks like the next interplanetary destination will be Mars.